Hi, welcome to this lesson on trigonometry, 2D and 3D problems, part 2. Let's have a look at question 5. P is the top of a flagpole and its base Q is in the same horizontal plane as the points A and B. The angle of elevation measured from P to B is Z. We are also given that AB is equal to D units, QAB is equal to X degrees, and QBA is equal to Y degrees. We want to derive a general formula H, which is the height of the flagpole. Okay, so if P is the top of the flagpole and Q is the base, then this base made with this floor, QAB, that must be perpendicular. That's really important because that gives us automatically a right angle triangle. We're told that the angle of elevation, so elevating from B to P, is this angle Z here. So that's within this triangle, PQB. So that's angle Z here, and this is the height H. And we're also told that AB, which is on the floor here, that is D units across, and angle QAB, which is on the floor, X degrees, and angle QBA on the floor is Y degrees. Okay, so now we need an expression for the height H. Okay, so first of all, what I can see here is that I have an angle, I know a side opposite, well, that's the side I want to work out, rather, and I have a hypotenuse and an adjacent length QB. Now, QB is also on this other triangle here, QAB, which has angle X, angle Y, length D. So because QB is a shared common side here, if I can work out length QB in this triangle, then I can translate that expression into this triangle. Then using this triangle, I can know an angle, an opposite side, and adjacent side, so I can use tan. So let's break that all down. So in triangle PQB, we have that tan of angle Z is going to be opposite, which is the height H, over adjacent, which is the length BQ. So therefore, H can be written as BQ times tan of angle Z. Okay, but I'm not going to stop there because I feel like I can work out BQ as well in terms of the other information I was given. So, in triangle QAB, we have the following. So this missing angle here must be 180 degrees minus the sum of those two angles, because of sum of angles in a triangle. If I add up all three of these, I get 180. Okay? And I want the length BQ. So I want a length, and I actually know an angle opposite it, and I know a length and another angle opposite it. So I can use the sine rule, right? So using the sine rule, I have that the length BQ divided by sine of the angle opposite it, which is X, is the same as another side length I know AB, which is D units, divided by sine of angle 180 degrees minus X plus Y. Okay, and then solving for BQ, we have, so if I cross multiply both sides by sine X, I have AB sine X all over sine of 180 degrees minus angle X plus Y. Okay, so BQ, AB was given as D units times sine of X, all divided by, now sine of 180 minus an angle, okay, from your cast diagram, that's going to give you in the second quadrant, okay, so it's going to be 180 degrees minus that angle. And because sine is positive in the second quadrant, it's just going to be sine of that angle, X plus Y. So there I've got an expression for BQ. So I can substitute that in now, and therefore say that H, an expression for H, is going to be D sine X, don't forget that times tan Z, all divided by sine of angle X plus Y. Okay, and I'll say that's an appropriate expression for H because that uses every single piece of given information, right? It has the length D units, it uses the angles X, Y, and Z. Okay, and then lastly, we want to find the value of H to the nearest meter if we're given the following information. Okay, so we derived a expression for H. It was D times sine of x times tan of z, all divided by sine of x plus y. Okay, so now let's put in that information. It's going to be 45 meters times the sine of x, which is 42 degrees, times tan of z, which is 25 degrees, all divided by the sine of x plus y, which is going to give you 62 degrees. So let's put that on a calculator. 45 sine of 42 degrees, tan of 25 degrees, all divided by sine of 62 degrees. And I get 15.9, which is approximately 16 meters to the nearest meter. All right, so this flagpole is approximately 16 meters. Okay, and that makes sense given the proportions in this diagram, because D was 45 meters, which is a long piece of that floor where the flagpole PQ is standing on. All right, so this is how we would do this type of question. I'll see you in the next one.